So what we're going to begin with is measures of central tendency. So this is something you can kind of think of. We've heard the word average. You've probably seen your average grade in the class, or the average score on some type of exam. There's really a couple different ways we can actually talk about an average. Okay. So we want to go through all the different ones and we want to see, is one going to be better than another in certain circumstances? So ultimately, an average is a number that is representative of a group. Or even potentially a characteristic. Okay? So think of, if I kind of talk about the average college student, according to a couple different sources online. The typical college student is going to be female. They will be 20 years old. They will live on campus. They work during the school year. They have a family with an annual income between $50,000 to $100,000. They sleep for 6 hours a night. They have $2,700 in credit card debt. And then in total, they're going to leave college with $21,000 in loans. So this just comes from a bunch of different studies across the board that people do to try to get some measure about what an everyday college student looks like. But you probably don't know anyone that's exactly this category or fits every single one of these criterias. You might have someone that has part of those categories, but you might not know anyone that has it. So this is okay, but it's kind of ambiguous that this is what our typical student should look like. So you may not know anyone that fits all of these categories. Okay. And that's perfectly okay. So kind of average can be ambiguous. So we have a couple different things that we use to kind of describe averages. And typically we're going to work with numerical data. We're not going to throw in these other categories that talk about, where they live, where they work, that kind of stuff. We're going to deal with everything dealing with numbers. Okay. Okay. So ultimately, there are 4 main types of average. And we're going to go through each of them. We have the mean, the median, the mode, and the mid-range. Okay. And so if you hear an ad that says you have an average salary of this, which one are they talking about? Most of the time it's going to be this mean. That's what you think of when you have average. But these other ones may be a better gauge of the actual information that's going on. But ultimately, each number or each type gives a number. Near the center of the data. So averages are referred to as measures of central tendency. Okay. So ultimately, it's up to the person to kind of pick which one is going to be a good representative. There might be multiple that are good representatives, and that's perfectly okay. But sometimes you're going to have one that clearly does not gauge what is going on realistically. So to kind of see that, we're going to work with a set of data, and we're going to continue and find all these different types of measures throughout the whole lecture. Okay? So we're going to consider an individual. Suppose you start a new job, or suppose you're on the market for a new job. And you come across a flyer or come across a position which advertises an average employee makes almost $150,000 a year. Seems like a pretty good gig. Okay? So this seems pretty good. So you decide to apply. Okay. And you're only entry level. So, okay, you decide to take it. You're going to get a kind of smaller amount of money, but that's okay because the average salary is 150. So there's probably a lot of room for you to be able to grow and you to gauge money. Okay. So you're offered a lower salary. So maybe you're offered around 50,000, but you decide to take it because the average employee makes 150. Okay? So there has to be room for you to grow. Well, not necessarily. So maybe instead you actually find out a flyer that has all the other employees and their salaries. So HR slipped up, you find a list of all employees in the building and their annual salary. So here is the employee, and here is their yearly salary. So remember, you're only making $50,000 a year, but you think, okay, that's all right. I'll get to that 150 eventually. So a different employee, Jerry, makes $58,000 a year. Kramer makes $65,000 a year. Newman, who is the owner of the company, makes $944,000 per year. George, nice low-level employee, is making $20K. Elaine is making $52K. Susan is making $51,000. Tim makes $53,000. Estelle makes $55,000. And Frank makes $50,000. So no longer does your $50,000 really seem that great. There's not many employees that are making a lot more than you. Really, you've got this one guy that's making buku bucks in comparison to everyone else. So your average is really getting skewed by this piece of information, which is a problem. Okay? So let's go ahead and work with this data and calculate our different types of averages. So the first one is going to be our mean. And this is likely what you think of when you think of the word average. So the arithmetic mean or just mean is symbolized one of two ways. It's symbolized by X with a bar above it, or what's known as the Greek letter mu. Okay? So X bar is going to be used when the mean of a sample of the entire population is calculated. Okay. While mu, so this is a Greek letter, it's a Greek word mu, this is used when the mean of the entire population is calculated. Realistically, if you use either one, it's not a huge deal. This is going to be the more common one that people use, but there is that small, slight difference between the two. But ultimately, the mean is calculated by adding up all the pieces of data and dividing by the number of pieces of data. Okay. So ultimately, our mean is found by adding together every single data value you have up to the very last one, and you divide it by the number of pieces of data. So if I have 10 salaries, I add all 10 salaries, divide by 10. The other way you might see this is with a sigma, and then you do an X to indicate you add all these together. So sigma really just stands for sum, another Greek letter. This way, if it pops up at any point, you're not concerned as where that comes from. Okay. So let's look at an example of this. We're going to calculate the mean of our different salaries for these employees. Okay. So for our example, let's find the mean salary between all the employees. Okay. I'm going to go ahead and bring this chart back down just so we have it. We want to go ahead, add up every single one of these values divided by the number of people there are. So our mean is going to be 58,000. So I'm just going to write 58 to ignore the zeros. 65,000, 944,000, 20,000, 52,000, 51,000, 53,000, 55,000, and then one last one of 50,000. So this adds together all the thousands of dollars there are, and in total we have 1, 2, 3, 4, 5, 6, 7, 8, 9 employees. So in the bottom, we're going to go ahead and divide by 9. Okay. So if you add all of these up, divide by 9, you're going to end up with 149.8. Okay. So the average employee is indeed making $149,000, which is right under that 150. Okay. So the mean salary is $149,800. So the flyer is truthful. But it's not realistic. Most employees aren't even near the salary. Okay. So it's quite deceiving. They didn't lie, but it's not really representative of their company. Okay. So instead, let's look at some different measures. Our second one is going to be the median. So the median, that wants to go, no, okay, is the value exactly in the middle of the data. Okay. But the thing you have to be careful with is you need to put that data in increasing order. You can use decreasing order, it doesn't make a difference, but you've got to put it in some type of order. So if there's an odd number of data points, the median is exactly in the middle. So there will be a single number that is directly in the center. If it's even, you really kind of have things split, so there's two numbers that will fall in the middle. So if there's an even number, the median is the mean of the middle two. So whatever two fall directly in the middle, you find the mean of those values. So add them together and divide it by 2. Okay. So let's work with our example. Bring this back down. Let's find the median salary between the employees. Okay. So again, I've got to put everything in order. Then I go ahead and see which one falls in the middle. So I need to pull my smallest salary. Let's get rid of all these highlights though. Our smallest salary is going to be poor George. He's only making 20,000. So that number is going to go first. Our next salary is going to be Frank, making 50,000. And you don't have to put the thousands. You can again put them just with the 20s, the 50s and all. Next person after that makes 51,000. Then we've got 52,000. 53,000. 55,000 comes after that. Then 58. Then 65. And then finally Newman's of 944,000. Okay. So I want the number that falls dead center of these. So what I tend to like to do is I like to cross off one on each end and then keep coming in until I get to the very middle. So I cross out one on each end, one on each end, one on each end. 53,000 is the number that falls directly in the middle. So here, the median salary is $53,000. Okay. And that one is much more reasonable than our mean. So, which is a much more reasonable average. Than the mean. Okay. So much, much, much better off. So we've got two more types to go over. The next one is our mode, which is a lot like that modal class. It stands for the most. So the mode is the piece of data that occurs most frequently. Okay. So if it happens to be that two pieces fall the same number of times, you can absolutely have two modes. You can have three modes, perfectly fine. So there can be multiple modes. If there's two, the data is called bimodal. So bi means two. Okay. But if it happens to be that every piece of data only occurs once, so there's no repeats, you're not going to have a mode. Not every single one can be there. So if each piece of data occurs only once, there is no mode. Okay. So if we go back up to all of our salaries, not a single one of these repeated, so there's no mode. I don't want to say this is mode. I don't want to say every single one of these is a mode because it all appears once. That's not going to be super useful or relevant information. So for our example, which we'll come back to again in a little bit, for our employees' salaries, for our employee salary data, there is no mode. Each salary appears only once. Okay. So again, not a great representation of our average because it doesn't tell us anything. Now our last piece of information is what's known as our mid-range. And so this in turn kind of finds an average between the highest and lowest value. So the mid-range of a set of data is found by the following. The mid-range is equal to the lowest value plus the highest value divided by 2. Okay. All right. So let's take a look at our employees, and we will find the mid-range. So let's find the mid-range for our employee salaries. So I want to take the highest piece of information plus the lowest piece and divide by 2. So here, the highest salary is, of course, Newman's, which is $944,000. The lowest salary is poor George, who's getting the short end of the stick. He's only making $20K. Okay. So the mid-range is going to be the sum of these. So $20,000 plus $944,000 divided by 2. So if you add those together, that's $964,000 divided by 2. The mid-range is $482,000. So realistically, he could have put this as the average salary on his flyer, but definitely not realistic. Okay. So the mid-range is way larger than the rest of the employees' salaries. So this is a poor representation of the average. Okay. So what you can kind of see in all of these, really just that median was the one that gave us the best representation, because this salary is really skewing everything so much. It made that mid-range gigantic. It made our mean gigantic. The only thing it didn't affect is that median. So this piece of information holds a lot of power. So we kind of call it an outlier because it doesn't kind of fit in with the rest of our employees. So instead, let's go back and calculate all of these same things without Newman's salary and see, do I get something that seems like a better representation of what's going on? Okay. So let's try another example. Let's compute the 4 types of averages for our employee salary excluding Newman's salary. So excluding Newman. All right. Oh, I've got too many things on my screen. Here we go. Okay. So let's go back up. Let's get all of our salaries once again. And we're going to go ahead and ex-nay Newman's. So Newman is gone. Okay. So let's first start with our mean. So I want to add together all the rest of the employees, divide by the number of employees we have. So our mean will be the 58,000, 65,000, 20,000, 52,000, 51,000, 53,000, 55,000, and 50,000. And now instead of 9 employees, I'm excluding Newman, so I only have 8 pieces of information that I'm adding together. So if you do that, you should get 404 in the numerator, 8 in the denominator. You find out your mean is 50.5. So when we included Newman, the mean salary was $149,800. It changes drastically when we exclude him. To $50,500, okay, which is much better at really talking about the average employee. So instead, if they had put this on the flyer, you might not have gone for it or not have taken that offer, because you getting $50,000, you're making about average. There's not going to be much room for growth instead. And you don't want that. You want to have an opportunity to gauge and go up. Now, if we go for the median, I again have to put all of these in order. So we got to start with our lowest, which is 20,000. Then we have 50,000, 51,000, 52,000, 53,000, 55,000, and we've got 58 and 65. So that gives us 1, 2, 3, 4, 5, 6, 7, 8 employees. Good. Okay. So again, we want the number that's right in the middle, but since this is an even amount of data, we take off 1 from each end, 1 from each end, 1 from each end. You have 2 numbers that fall exactly in the middle. So our median is going to be the sum of these, so 52 plus 53 divided by 2, which is 105 divided by 2, or 52.5. Okay. So even when we include a Newman, our mean was 53. It doesn't change much when we exclude him, which tells us this is a pretty good representation of our data. Okay. So when we include a Newman, the median was equal to 53,000. When excluding Newman, the median is 52,500. So it doesn't change much even with that piece of information. This is going to be a decent average. So this doesn't change much when excluding the outlier. So this is a decent representation of the average. Probably the best one we have. Okay. Now when it gets to mode, there's still no mode. No number repeats multiple times, so can't do anything with that. And so we have one more, our mid-range. And so for the mid-range, we're going to take the highest and lowest value, divide it by 2. So let's see. I need to pull this in my calculator because I don't think what I have is right. So our highest value is 65,000 without Newman. Our lowest value is the 20,000. So the mid-range is going to be the sum of these, so 20,000 plus 65,000 divided by 2. That's 85,000 divided by 2, and that's going to be 42,500. So that also changed drastically, which not very good to happen. So when including Newman, the mid-range was a whopping 482,000. When excluding Newman, it changes and it even goes lower than most of our information. Okay. So still not fantastic for anything that we have, because the 42,000 is still under a lot of our employees. So either way, our median is going to be the best in both circumstances. When you exclude that outlier, then you also get a good measure of the average from that mean. Okay. So when you're looking through and you're going and doing your projects, make sure you're kind of taking a look. Do you have a number that's really far out there, or do you have like 1 or 2 that are really skewing your pieces of information? Maybe you're surveying them about how much money they spend in something. Most people you find only have like $100, or they're in the like $0 to $500 range. But you got this random whale that's spending like $50,000. Probably going to skew everything imaginable. So make sure you calculate it both ways. So just take a look, really try to interpret what's going on. to be able to get a decent sense of that average. Okay. All right. So hopefully this kind of gives the importance of why we have different types of averages and why some can be beneficial in versus of others. I really just have one more example that I'm going to go through that's not related to these salaries, at least, to get some practice with other types of problems. Okay. So we're told about an average on some examinations, and this can happen to you. You might be like, okay, I got these on my first 5 tests. This is the score I have to get on this last test to be able to get this grade in the class. We're going to figure out how to do that. So we're told a mean average of 60 on 7 exams is needed to pass a course. Okay. On her first exams, Cheryl received grades of a 52, a 72, an 80, 65, 57, and 69. For the first part, what grade must she receive to pass the course? Okay. And then we put receive on her last test, so it's a little more clear. So I have no idea what her grade is. That's the unknown. We're going to let that be a value x. So let x be the grade on her last exam. Okay. Her mean average is 60. So that's x bar. We know that it has to be 60. So ultimately, we can set up an equation. 60 has to be her total average on her 7 exams. So we have 7 pieces of data we're going to add together. And the numerator has to be all of her grades on the test. That would be a 52, a 72, 80, 65, 57, 69, and then finally this unknown grade of x. That's 1, 2, 3, 4, 5, 6, 7 pieces of information. And so all we need to do is now utilize this equation, solve for x. So I'm going to trust you can plug things into your calculator. Got 60 over here. If you go ahead and add all of these together, you should find that their sum is 395. And then you still got this unknown x. Okay. And you want to get x on its own, so you need to get rid of the 7 in the denominator. So go ahead and multiply both sides by it, so they cancel. 7 times 60 will be 420. And that's 395 plus x left over here. Then we need to get x by itself. So we're going to get rid of the 395 by subtracting it. So this way these cancel. If you do 420 minus 395, she only needs a 25 on this last test to pass the class. So she needs at least a 25 to pass the class, which is fantastic. Okay. So very likely she's going to pass that given her history and all the other exams. Now, let's try it again. That's passing, but maybe she wants to do a little better than passing. So maybe an average of 70 is needed to get a C. Can she get one? If so, what grade does she need? Okay. So instead of needing a 60 average, she needs a 70 average to get a C. So nothing really changes in our average, except instead of a 60 over here, we have a 70. So you solve it exactly the same way. 70 will equal 395 plus x over 7. You go ahead, multiply by 7 on both sides to make these cancel. And that gives us 490 is 395 plus x. And then we go ahead and subtract 395 from both sides. So these cancel, and we are left with 95 on this side. Okay. So she can get a C, but she needs at least a 95 on this test. Which is a little problematic. That's going to be much harder given her track record because the highest grade she's gotten so far has been an 80. So that's a little bit less likely. Okay. But now let's add in an extra caveat. Maybe you get a drop test like we do in this class. If her lowest grade is dropped, what grade must she get on her last exam to get a C? Okay. So of all of our scores, this 52 is going to disappear. That is her lowest grade. And now instead of having 7 tests, only 6 are going to count. Okay. So here, the 52 gets dropped. And now we have 6 data points. Or 6 test scores. Okay. So you still need a 70 as your average, but you no longer need that 52. So you have a 72, an 80, a 65, a 57, a 69, and then our last exam of an X. And instead of dealing with 7 tests, you have 6, so we divide by 6 instead to find the average. And now, same thing, solve it the same way, but since I no longer have that 52, this will add up to 343 plus x. Go ahead and multiply both sides by 6 to make those cancel. That gives us 420 is 343 plus x. Subtract that 343 to make those cancel. And that gives us 77 is x. So instead of needing a 400 or a 95 or better, she needs a 77 or better with that drop exam, which is much more reasonable because she's actually been able to get above a 77.